Hey everyone, my name's Amanda, and today I'm going to be talking to you a little bit about why your API is bad and why you should feel bad. So who am I to be judging you? I've been doing this for a while, over 10 years now, building APIs, using APIs, started with things that were in libraries and kind of learned what an API was from that, and then gradually got into web development and started to learn more about web APIs. So why should you care about APIs? They're everywhere, literally everywhere. So with this whole Internet of Things terminology being thrown around, I mean, everybody is basically racing to set up an API for one thing or another. So they're becoming really, really common, and they have been for a while. So why do you care about having an API in the first place? And the whole idea is basically to provide a uniform interface for your users to interact with whatever service you're schlepping. And it also lends itself to service-oriented architecture, which I'm totally into. So it allows you to decouple services, and basically things can go down and you don't really have to care about it. So that's great, and that's one of the reasons why people are spinning this up instead of having like monolithic applications that are tightly coupled. So like I said, types of APIs, there are language and platform-specific ones. Today we're going to be talking about web APIs because that's kind of the direction that everything is headed. Like I said, with this Internet of Things, which I don't know how that got more popular than cloud, by the way, but everybody is like super excited about Internet of Things. So this is one of the common ones, SOAP. I see some head shaking in the audience. I'm sure you're familiar. Yes, exactly. So SOAP actually does have its uses. We're not really going to talk about SOAP today because really nobody enjoys using SOAP. It's just one of those things that you have to suffer through, right? So it's great because the procedures are mostly obvious, but also sucks because, well, you can read the slide. So we're going to talk about REST. It's gaining adoption. It's becoming super common. It's been around for a while, but people, for whatever reason, have just started within the last few years to pick up on it, that it's actually a thing. So it's usually HTTP based, which is great because anything that speaks HTTP, and pretty much every language has some sort of HTTP speaking thing, can talk to a REST API. And there's really no need to know the order of the parameters like you do with SOAP. And it can return all sorts of formats. There are people that are returning like custom formats and then the standards like XML, JSON, YAML, things like that. So you're probably thinking like, okay, well that sounds great. That sounds easy enough. You know, there's all these things out there that will help me do this. And well, no, this is the first mistake that people make when it comes to them trying to get an API out the door. They rush into it, they rush to get V1 released, and it's a terrible experience. And then V2 is usually not too far around the corner. And then usually V2, since they're in such a hurry to fix V1, V2 also gets rushed, and we're going to talk about that. So the best design is the simplest one that works, and that's kind of the idea behind API design. So you want to design for simplicity, but whatever's going to work for you. So you want the shortest path but also the most well thought out path. And it's very difficult to do. So slow down. Don't rush into V1. Make sure you're meeting your goals. You really need to put a lot of time into designing your API so that people, you know, they will be able to interact with your service in a way that they expect. So there are a lot of people that are putting out completely useless APIs based on things that they think are useful, and they're not actually talking to the people who are going to be consuming the service to find out what they want in the first place. So I always advise people to involve engineers from the start. They're usually pretty judgmental and will tell you that your crap sucks. Like I said, this is very hard to do. There are a lot of people who don't like hearing that something that they've designed is crap. So they hesitate to share it with people, even though that's the most valuable thing that you can do. So just to put some context for a slide that I'm going to show, it's part of a DNSBL project. That's why I make references to APIs and reports, things like that. Not super interesting. So here, this is part of the design process, and people think, oh, you know, we need to do this all in a Google Doc or like some huge thing. Really, like I just wrote crap down in a notebook and it works pretty well. So this is designed to be a blueprint between you and your engineering team or your users. It's immutable. The worst feedback, like I said, the worst feedback is the feedback you don't hear. Like you really do need to share this, even if it's just scribbling in a notebook. Like I'm not afraid to show this to people and say, hey, does this meet your needs? And 9 times out of 10 people are like, actually, no, that really doesn't. Why don't you try adding something like this? And then, you just iterate over this design before you actually even get to building anything. And you'd be amazed at how many people don't actually do this step. They just start hacking on something, they get really excited about it, and then they just release crap into the wild. Really important to know your audience, know who you're making this for, whether it's an internal stakeholder or, third parties. If you have platform as a service, it's really important that, you talk to the people who are going to be building on top of your platform to really get them immersed into this. They need to have an incentive to use it. So a lot of people who don't make an API for people to use, they have some scaling issues because people are perpetually crawling their website to get the data that they need and parsing HTML. And it's a terrible experience for them. It's a terrible experience for you if you have to deal with that traffic. So there needs to be some sort of incentive. And the only real way to find out what is going to provide value to these people is to actually talk to them. So I can't stress that enough. You need to be talking to these people. Ask, ask what people are going to need. It's sort of like old school software architecture where you get everybody in a room, you get a bunch of stakeholders together and you're like, okay, what do you need from me? And the process, like, I'm not going to lie to you, it sucks. It sucks to bring everybody into a room and be like, okay, well, what do you need from me? And usually I call them rage domes because it's usually a bunch of people that get in a room and get like very heated about this sort of thing, about what they need versus, what marketing can sell. So there are a whole bunch of tools that'll help you do this. Like I said, you can write this down on paper. If you want to get a little bit more complicated, there are tools like Apiary, Swagger, and Raml that are either Markdown based or YAML based that'll allow you to really blueprint this out. And that lends itself to using tools that will kind of automatically either generate SDKs for you or allow you to have like an interactive experience. So they set up like a dummy endpoint for you so that you can test these things, which is actually really cool. And I highly recommend that people go that route after you've done your scribbling in your notebook, because it makes it super easy for you to hand someone a link to like an apiary thing and be like, hey, go test this out, see if this is what you're looking for. So what is REST? That's the thing that we're actually going to be talking about today. It's representational state transfer. So like I said, usually HTTP based, doesn't necessarily have to be. REST is more of a methodology for navigating things and not necessarily protocol specific. And it's stateless, so there are no sessions, whereas with SOAP there can be. And the server is storing a lot of that session data. And that's, a lot of people really don't like that facet of it for some reason, but it's actually really one of the benefits because the server doesn't have to do a whole bunch of processing to figure out the state. It's kind of a choose your own adventure sort of system. So just to recap, resources, pretty simple. It's a gateway to an area of the application. It's an endpoint to something. So CRUD actions can be performed, so you can create things, delete things, update things, whatever. Won't get too far into that. I assume most of you know. So now we get into action verbs. And this is another area where things start to fall apart, is that people make assumptions about these action verbs, put and post and things. They kind of shouldn't. And they're really obvious once you hear about them. But as you're designing an API, it's kind of incredible to me how many people don't take this into consideration. They don't do the research for these sorts of things. So getting data obviously gets data from a resource. You do this daily by browsing the web. If you're not familiar, that is a GET request to fetch that website for you. Uses query strings to tell the API what to retrieve, returns 200 if everything's okay. And I'll get back to that in a second. Posts, obviously used to post data. And people forget that 201 created is actually a thing. I can't tell you how many APIs I've seen that actually return 200, everything's okay, or 204, no body, for creating something. And that's really bad and actually not all that useful to someone who's trying to consume your API. Like, a large majority of people forget about this for some reason. So HTTP codes, they're kind of an awesome thing, and you should really be looking at them. Also, people forget to return the URI to the thing that they created. So people end up having to do more calls in order to figure out what the ID of the thing that they just created is. And it's a really terrible experience for them, right? Put, same sort of deal. People confuse put and patch, which we'll get to patch in a second. Put actually overwrites the existing object with a new one, and should return 201 if you do this right. Lots of people return 200 or nothing at all after a put request. You don't necessarily have to allow it to overwrite the object. You can say, no, we're not going to allow you to overwrite that. Like, you need to be using patch to do that. And kind of sucks because it's inconsistent. People do different things, so it's not a standardized behavior across APIs. There are people that are working to change that. Unfortunately, it's not happening quick enough. Patch updates only the properties provided in the call. People, again, like 200 on successful update, that's pretty common, but people will 200 if nothing has changed, so you don't actually know the state. And the whole point of REST is so that the server is not keeping track of state, you're keeping track of state. So how are you going to keep track of state of things if you don't actually get information about what the state of that is? Lots of people not doing this for some reason unknown to me. Delete. This one is pretty dangerous. People actually allow you to delete an entire collection of things. So you can realistically delete all of your users. And people don't cover that for some reason. They just, okay, delete whatever you want. So that's really dangerous. HTTP codes, 200 if it was deleted, 204 if there's no body to return, which is pretty standard. People do tend to return 204 if something was deleted. And for cases of CDNs, you can return 202 if the cache is going to be deleted after a certain period of time or whatever. So you can queue it. Is there a question? Okay. And this is one that I don't see an awful lot, the options header. So it's not for interacting with data. It's purely informational. It allows you to tell your users what methods they can perform. Super helpful if you're trying to keep track of the state of something. So, you can set this up so that certain resources only have certain methods, and that's an ideal way. But a lot of people, they just don't return this at all, or they return 405 method not allowed, which, like, if you're going to the effort of responding to that, you may as well just allow options. So content types, the thing that sucks is when you use an API and it doesn't return what you want. So lots of people are using JSON. Some people need XML. I actually had a guy email me because PagerDuty's API is only JSON, and we don't send XML. He was trying to use the PagerDuty API to send alerts from a Cisco router, which speaks XML natively. So he was going to have to do some hackery to get the JSON into XML in order to basically use our API to be useful for him, which sucks. I mean, he was actually kind of mad, and I don't really blame him. So that's something that I feel bad about for our API because it is bad for him. If you only allow one type, inform people that others aren't allowed. There are APIs that don't do this, and they have terrible documentation, so you don't actually know what they accept. Not all that useful. You can use content type to receive and parse client data. You can get a little crazy with this, so you can have people send you XML and receive JSON, which is cool. If you're just getting started, I don't recommend that you do that because it's kind of an architectural nightmare if you don't really know what you're doing. And for replying, this is probably one of those things that pisses me off the most. It's people who either just send HTTP codes and expect you to guess what the problem is if it's not 200 okay, and they don't send any sort of error message with it. And that to me is one of the absolute worst things that you can do, or not do, as it were. So I tell people, like, okay, if you're going to send 403 forbidden, at least tell them why that request didn't work. Give them something. Even if you don't want to be specific about the API key, your user doesn't have access to this. Something other than just an HTTP code. And it's great because, then the API client can decide, hey, well, I got this error, which was well documented. Why don't I try doing something else instead? And you can really let the client make those judgment calls. The crappy part is that there's no standardization for error messages, so you can make these up, make them as great or as terrible as you want them to be. So Google errors and JSON API, they're trying. Adoption has been kind of wishy-washy, but if you're going to get into making an API, that's definitely something to take a look at, because they're really trying to push people to provide error messages that are consistent across different experiences. HATEOAS, and there's some arguments as to how this is actually pronounced. Doesn't matter. It's Hypermedia as the engine of application state. So, like I was saying, REST is stateless, so it's up to the API client to decide, what the state of things is, and it's choose your own adventure for navigation. So you can provide the client with a list of endpoints that they can hit. So, if you have like an IP object and you're trying to manipulate that, you might provide them with update this entry or delete this entry, or make a new entry if you want, and kind of you can let the API client really navigate that so that they're not forced to hard code things within the SDK. They're going to do it anyway. People like to hard code things, so you can't really prevent that from happening, but you can at least provide them an alternative that is hopefully a little bit better for them. So downside, there are no Hypermedia specs. There are people who are trying, but again, there's no consistent way to handle this. People can kind of make up their own URL structure. I've seen people, insert like random gibberish into the URL because it's obscure, and that's how they're hiding their endpoints, and it's just bad. It's all kinds of sad. So you can use a JSON API. You can make up your own, like I said. HAL, they're good starting points. HAL and JSON API are good starting points for at least trying to get some standardization. So if you're looking to dabble in Hypermedia, you don't necessarily have to do this with REST. You can. If you're looking to dabble, those are definitely good places to start. And now the thing that everybody hates about APIs, versioning. So I see a lot of people cowboy through this. So they released V1, and V1 is just terrible. It's the biggest pile of crap. They get all this negative feedback, and they're like, okay, well, we're just going to iterate on this, and we're going to release as many versions of this as possible. Well, that's great, and it's nice that people want to provide for their users, but ultimately you're stuck maintaining all of those because people rely on this. A version of an API is a contract between you and your users. So you don't want to have a ton of different API versions for them to get confused about, and especially like trying to document that is just ridiculous. Like you're going to sink, and yeah, having to maintain all the SDKs and the documentation for that is just it's hard. And you should always deprecate carefully. So once it's out there, it's out there. You can't take it back. So you really need to give people time. Like if you're going to cowboy through a release, or even if you're just releasing V2 and it's like the latest and greatest thing, and angels cry tears of joy at V2 of your API, you can't just get rid of V1. V1 is going to be around for a while. Developers, like if it's working, they're not going to touch it. So, you're not going to get them to move off of your API without some sort of incentive to do so. And oftentimes V2 is better is not good enough for these people. They don't want to hear it. So when to version, backwards incompatible changes, and people get confused about this. You don't need to version your API if you add new resources or data fields. In theory, the SDK should be able to handle that, or people should be designing their communication methods with your API in a way that it doesn't barf if you do something like this. People tend to, bump their version of their API, even if it's like a minor revision when they add new resources, and you don't necessarily have to do that. Like I said, architect things so that you don't necessarily care. You don't care about the order of the parameters. So if you're getting data back from the API that you don't know what to do with, you can ignore it. And that's one of the really great things. So there are a few ways that people do this. Putting it in the URL is super common. It's great for people who are just getting into consuming APIs because it's very obvious what version they're using. The downside is that your relative paths can get kind of screwed up, and especially if you've got different versions of the API and people are trying to consume both at the same time, like it doesn't work at all. And this is my favorite, putting the version in the content type. It's cleaner, it's not as obvious, and I like it because you can default to a version if none is specified. There's nothing, you don't need to edit a URL. It can be mostly invisible to people who don't necessarily know what they're doing. So it's kind of, in a way, it's beginner friendly, but also cool for people who have experience with things like this. The crappy part is that devs need to know that they need to send this, and it's one of those things that's missing from a large percentage of documentation that I see. People are just like, oh, well, don't worry about it because we're going to default to a version. But just because you're defaulting to a version doesn't mean that you can't document it. That's not how the world works. And this one, I really kind of loathe this. So there's minimal standardization around this. So people create their own custom header with the version in it, and it's like, that's not consistent at all across APIs. So people have called it version, people call it my app. I've seen like random words like kitten for an API, which doesn't, that's useless. So it requires great documentation. And unfortunately, most APIs have terrible documentation. There's not a whole lot of examples of great API documentation out there. And it's confusing to users who aren't expecting it. My first thought when I'm looking to consume something is not, oh, well, what crazy custom version header do I need to send in order to get this to work? And usually the examples that I've seen, people don't default to a specific version. So like if you don't send that header, you're not going to get you don't get V2, you just get nothing, which is also a terrible experience. Also, everyone's favorite next to versioning. So caching. A lot of people leave this out of their SDKs for some reason. It's one of the great things is that if you're making calls that really aren't necessarily changing a whole lot, cache it on the client end. Make that available. There's a cache control header, and it'll save you some scaling pains as people try to get data. They're not necessarily hitting your API if the data that they have really hasn't changed and is readily available to them. Really super important that this end up in the documentation. There are a few cases that I have seen where people, they have it in their SDK, but they leave it out of their documentation for whatever reason. And people, they kind of roll their own solutions for caching, which really kind of sucks. And this is probably the worst part of every API. Dealing with authentication. And I really have a thing against basic auth because I've seen a lot of people get bitten by their credentials either being stored in a browser or being in their bash history or something. There are so many ways that just can bite you in the ass so bad. So these days I tend to recommend that people use like OAuth or something like that. So requiring users to explicitly authorize the application so that they're aware of what they do and do not have access to, how they are going to allow interaction between whatever app and the API. I can't stress enough, you need to restrict this to HTTPS. Even if you're going to use basic auth, like absolutely HTTPS, but OAuth actually requires it. I like to restrict the domains that are allowed to authenticate as well. So, I've seen people who don't necessarily know what they're doing. They put their tokens or their keys in JavaScript and then serve that to somebody. So then, yeah, that happens a lot. If you go on GitHub and search for like Twilio keys or like Linode API keys, there are a lot of results, and it's really scary. So if you have an API like and it's public, like do yourself a favor and like be proactive about finding things like that. You know, look on GitHub for keys for your service and deactivate them immediately. Because I mean that's probably one of the biggest routes of abuse, is just people committing that crap to GitHub and it getting stored in Google forever. So security, don't rely on a single method. I see a lot of that. People are like, oh, I got tokens, that's fine. Well, no, not really. So I treat all users as if they're hostile, and 9 times out of 10 they are. So you really have to apply layers of security. So you've got your permission-based API keys, your tokens or whatever. I use the DNSBL as well to prevent people from using Tor to load up a bunch of crap. I wouldn't rely on a DNSBL alone. There are people who do with mixed results. I wouldn't. Another thing that people don't necessarily think of is content length and depth limits. So they get into these recursive JSON replies that can basically exhaust the resources on your server. A lot of people don't know to think about that. So you can limit the content length that you're being sent and that you're sending back, and also depth limits. So people can't do recursive requests like that. Still need to worry about SQL injection. And I speak to a lot of people who don't think that this is an issue because it's not a traditional website, but it kind of is. So yeah, it's bad. So you do still need to be worried about that. You need to be worried about the typical things, treat it as if it was a website that was basically just returning plain text. And also rate limiting and throttling. Those are generally a good idea. There are different approaches to that, and honestly, like that could be an entire talk on its own. So I'm not gonna dive too far into that. So now that you know a little bit about what you're doing, there are so many ways to prototype these things quickly. So once you've got your design figured out and you've sat down with engineers and you've put some thought into this, what methods you're going to allow for different resources. Prototyping these days is super quick. I tend to stick to Laravel just because I'm a PHP person, but there are frameworks for every language that have RESTful HTTP routing. Makes it super easy to get started. So I use Laravel, zeroed API in like an hour worth of work. I mean, it's pretty painless. And then for, like I mentioned earlier, there's different specs and things. Some frameworks allow importing of specs. There's actually like a Modulicious thing that will read apiary specs. So it's like markdown formatted, and it'll pretty much spin up an API for you. Yeah, it's great. And then there are also tools that will generate an SDK for you so that you don't even have to spend engineering resources generating an SDK. For those things, I mean, they're kind of hit or miss. So definitely don't just say, okay, give me a Ruby SDK and then call it good and then start releasing that. Like, you really do need to look into the code behind it, because sometimes they're not good. And then there are all sorts of tools to help you debug. I actually send JS fiddles to people when I'm testing API things, and it's super easy for them to see, like, oh yeah, this is giving me the information I need, and they can see how to interact with the API like super quickly. So now what? Here is where things just completely go off the rails. People are like, oh, I released an API. I've got some really janky documentation, like calling it good. And they don't think ahead long-term about the maintenance. So, plan to maintain your API, your SDK, and your documentation in parallel. If you can auto-generate it, definitely do that because it'll make your life a lot easier. If you use like a spec tool, so like Apiary or something, then it'll be a lot easier for you to kind of keep everything in sync. So everything is written to that spec. Your SDKs will always follow that spec. So it'll make life a little bit easier on you. Thing that people do is they launch it and then they leave it alone. And they don't even provide avenues really to get support beyond like submit a ticket and maybe we'll get back to you. Or worse, they do something like, this is a paid service, so our API is free, but if you want help with it, then that's going to be $1,000 a month. Sorry. I tend to like the community approach, so it's great. If you're offering an API, you should have a way to support it, and if it's paid, like whatever, just have some way for people to get help. I like the community approach. In my experience, communities sometimes can be better at supporting a product than you can. So I usually like to rally some people to help other people out, and that's an approach that's worked pretty well for me. And this is things that bad people do. If you're doing this, like, we need to talk, because this is not okay. Logging into view API docs, like, why? Why would you do that? And it's also counter to open source to use documentation as a lead generation tool. Like, that's awful. If you are making people create accounts to view your documentation to see if something will work for them in order to try and sell them on something, that's bad. Don't do that. People using HTTP see that a lot, or not default. They offer HTTP and HTTPS in parallel, but they don't default or force HTTPS. So people can use their API over HTTP, and that's not good either. The worst thing you can do is no documentation at all. The API is completely useless if people don't know how to use it. If you are the only people that know how to use your API, then it's only useful for you. If you're building an API for yourself, that's great. But if you get hit by a bus and someone else depends on it, then you should maybe have some documentation that someone else can take over. And basic auth or requiring the username and password in the URL structure. People do that a lot too. And that's bad. Like I said, that can be saved in your browser. It can be saved via CLI in your bash history. So just try not to do that if you can. And SDKs. So these are semi-optional. Like, it's nice when you provide them to your users, but if your users really like your product, they're just going to make their own anyway. And sometimes, that meets their needs better than whatever you're putting out. So I encourage people to do this. You don't necessarily have to do this, but it should have a maintenance plan like your API. So anytime you make changes to your API, you need to make sure that your SDKs are up to date. And that I see a lot of is, people will release version 2 and their SDK will be several revisions behind. And these really need to be made by language experts. I'm a PHP person, so I do PHP stuff. If you try to have me do like Ruby stuff, like, I can wade through it, but I'm not going to be as good at it as a Ruby person, or have Perl people make the Perl things and Python people make the Python things. There's no one size fits all sort of thing when it comes to this. And there are, like I said, there are tools that will generate these for you, but you really need to have someone who knows what they're doing, like, go through that and make sure that that's the best way to do it. Make sure that, there's not something glaringly wrong with it. And I can't stress enough the documentation. It needs to be a part of your design process. Like, as you're designing this thing, you need to be thinking, okay, how am I documenting this? So ideally, auto-generation. If you don't have the resources to make that happen, because it can be a little involved, then, just something is better than nothing. Ideally, it's all-inclusive. People will be able to go there and use it as a tutorial or also a reference. So you really need to provide as much information to these people as possible, because you never know who's going to be consuming your API. Sometimes it's experienced users and they just need to look up a few things and they're good to go. Sometimes it's someone who's completely new to programming in general and just like, they need to see that curl example to understand, like, hey, I need to paste this thing and then I'm going to get this thing back, and kind of helps their learning process a little bit. Include how to get help. And I'm also a huge fan of open sourcing your documentation. So that's one of the things that I do pretty frequently. And even if your formatting is crap on your documentation, like there's still an opportunity for the community to get involved and help you out with some of this documentation stuff. So that's one of the things I've seen on a few of my projects is like my documentation gets out of date. I fall victim to this as well, and people help me out. They're happy to be like, oh well, I noticed this thing and I'm getting this response, but this example says this, and they submit a pull request, and it's super easy. And people kind of are afraid that they're going to get judged for their documentation, and there are people that are going to judge you, but more often than not, people, they really want to help you with this. They really want to help make the project better. And above all else, the best API is the one that exists. I'm really a huge fan of providing an interface for people to get the information that they need. There's this day and age, there's really no reason someone should have to scrape your site to get the information that they need. It's a terrible, terrible experience for them. So, go forth and prosper. Make your APIs awesome. It's just a few resources. Build APIs You Won't Hate and Undisturbed REST are two pretty decent books on, they get more in depth into like the REST itself. So there's more theory, few code examples. Build APIs You Won't Hate actually uses the Laravel PHP framework. So you can copy the code from GitHub and stand up a basic API. He makes like a fake Foursquare sort of thing. And it'll take you 10 minutes of work to get that stood up and get you kind of ready to go. Apiary is the tool that I use to actually blueprint the APIs that I design. RESTful Web APIs is a book printed by O'Reilly that's really good. It was released 2 years ago or so, so it's actually still pretty current. Things haven't changed too much. A few of the code samples are a little out of date, but other than that, it's a fantastic book. It's only a few hundred pages, which for an O'Reilly book is actually pretty good. So thank you. Are there any questions? Yeah.
What I find difficult about REST is encapsulation. Like every API has a different way of representing an object.
For me, so the question was encapsulation and standardization of formatting. So for me, it's kind of varied by project. So that's kind of why there really isn't a standardization of that. That's why like you return JSON or XML, and that's pretty much as good as that gets. So there are people who are trying to standardize those replies a little bit better, but I mean, there's some traction for some, like traction for another. It's kind of chaotic since this is relatively new still. So unfortunately, I don't really have an answer for you. Good question. So for an example of an API, I really like to look to Twilio, and their API is not entirely perfect, but it's pretty good. And their ecosystem around their API is fantastic. So they have code samples in like 8 different languages, including Cold Fusion. And yeah, and their SDKs are always up to date. So just overall really good user experience from them. So I would look to them even if what they're doing is not completely like RESTful. Anyone else? Okay. Yeah, put. Is that a question? Yeah, so I hear that a lot. People like to know that a resource is created. Well, it depends on how you set up the API. So sometimes it's a replacement. Sometimes you can set it up to create. So different APIs will have different behavior for that. Yeah, but some people are using put for create. I think there was a note in the slide about that. Yeah, so that's, Yeah, well, yeah, I agree, but not everybody does that. For put? Yeah, I mean, if a resource is getting created on a put and you're applying 200 OK and not actually like either giving them an updated URI or telling them that something has changed, that's bad. If you submit a put and everything gets replaced and that's you're not expecting that and you just get 200 OK, it's like okay. What if the resource already existed? There's so many other things that come into play there, so you just really need to be careful about that. Mm-hmm. You asking like what the best method of authentication would be, or? Mm-hmm. I am a fan of OAuth, but I mean, honestly, I really don't have a preference as long as it's not basic auth. That's pretty much my answer. So I've seen a lot of different ways to tackle that problem. Use the one that works for you. I actually don't have much experience with that. I've seen it and I've been seeing more and more about it, but it's just not something that I'm familiar with. Okay. Okay. Yeah, I absolutely agree with that. It's like rolling your own crypto. Just don't do it. Anything else? If not, I will stop talking at you. All right, thank you.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.